Hi, welcome to this section where I'm going to be teaching you how you can visualize your data using the ggplot2 library. So the ggplot2 library is a package in the tidyverse that is used for visualizing data. It allows you to visualize your data using the grammar of graphics. So it's just like a step. So when you finish a particular step, you go to the next step. So it's built based on the grammar of graphics. So for you to install the ggplot2 library, you need to call the install.package function. Install.package function. You say ggplot2. So this is how you install it. I already have it installed on my PC, so I'm not going to install it. Then if you want to load it, you call the library function ggplot2. So as you can see it now, ggplot2. So this is for installing, and this is for loading. So if you don't have it on your PC, you can install it using this line of code, and after installing it, then you can now load it using the library ggplot2. So this section we're going to be talking about how you can visualize your data. It's one of the most popular, or even the most popular visualization package in R, and it is a very good package. So all throughout this section, we are going to be making use of this package, and I'm going to be showing you how you can perform various types of visualization using this ggplot2 package. In this lecture, I'm going to be showing you data sets we are going to be using. We are going to be using two data sets in this section to show you how you can visualize your data using ggplot2 library. These two data sets we are going to be using comes with the ggplot2 library. So it is called the diamonds. We have the diamonds data set and we have the economics time series data sets. These are the two data sets we are going to be using throughout this section to show you how you can visualize your data using ggplot2. You just need to load the library. If you have the library loaded, you can call the data set. The diamonds, let me call it diamonds, and run it, control enter. You can see the diamonds dataset is in a tuple format. We are having 10 columns and we have 53,940 rows. You can see we have the diamond carat. So this is the unit of measurement of a diamond's weight. We have the diamond cut. Which kind of cut is the diamond is, which is actually a categorical variable. You can see it is ordinal variable, which means we have premium diamonds, which are the best diamonds. We have very good diamonds, we have good diamonds, then we have ideal diamonds. Then we have diamond color. You can see we have diamond color. It is also an ordinal variable. We have diamond clarity, as you are seeing here. We also have the depth of a diamond. We have the table of the diamond. Then we have the price of the diamond. So if you want to know more about the data, you can just come to your console here, question mark, diamonds. And you run it, so you can see this is the detailed documentation of the diamond data set. So you can see, as I mentioned here, this is the length of the diamond. So X is actually the length of the diamond. We have Y, which is the width of the diamond in millimeters, Y, and we also have Z, which is the depth in millimeters. So this is the variables X, Y, and Z. At least we know what it means now. You can see the clarity. They say it is a measurement of how clear a diamond is. So from worst is an ordinal variable, so from worst to the best, which means SI2, SI1, VS2. So the higher we go, we can see that the best clarity of the diamond is IF. Then we also have the color of the diamond, as you are seeing here. We have the diamond color from D, the best diamond color, to J, which is the worst diamond color. This is also an ordinal variable. We also have cuts from quality, based on the quality of the cuts. We have fair, good, very good, premium, and also ideal. Then we also have diamond carats, as you are seeing here, weight of the diamond. Then we also have the diamond price in US dollars. So we're going to be making use of all these variables to answer some questions about the diamonds. So I'm going to be showing you how we are going to use the ggplot2 library to answer some questions regarding this data. So next we have the economics data. The economics data is also another data that I'm going to be using in this section to show you how you can perform some data visualization in ggplot2, especially time series graph. How you can plot a time series graph. That's why I choose to use this data, and I'm going to also explain further on it when you reach the section of plotting line graphs. So you can also call the economics data using economics. So you can see we have the data. So let's check more on this data. We use question mark the economics. We want to know more about our data. You can see that this data was produced from US economics time series data. We have a data frame of 574 rows and 6 variables. So in this data, we are dealing with mostly a time series data. That is a data that is ordered by time. So it's based on time. We have months of data collection. So let me minimize this. So we have the months of data collection. This is the date, months of data collection. Then we have personal consumption expenditures in billions of dollars. So this is the personal consumption expenditures in billions of dollars for US. This is how much they have consumed. Then we also have POP, total population in thousands. Then we have PS AVAT, personal savings rate. We have UEMP MED, variable unemployed column, which is the median duration of unemployment. We also have unemployed, number of unemployed in thousands. Then the median duration of unemployment also in weeks. So we're going to be talking about bar plots in this lecture. I'm going to be showing you how you can plot a bar graph using ggplot2. So we're going to answer a question based on, we want to know now the most highly occurring or frequently occurring cut of diamond. So let me head diamonds. So these are diamonds data sets as you are seeing. Now I want to know which of these cuts occurs frequently or is the most in this data. So it's just like knowing the most, or let's say knowing the mode of our data, the highly occurring diamond cuts. So how do I actually answer this question? Using a graph, and this kind of graph is called a vertical bar plot. We have 4 types of bar plots. We have vertical bar plots, we have horizontal bar plots, we have stacked bar plots, and also have group bar plots. So the graph I'm going to be plotting now for the most highly occurring diamond cuts is called the vertical bar plot. And I told you already that the ggplot2 library is based on the grammar of graphics. So this is how it goes. First of all, you type in the name of your data, which is diamonds. Then you pass this to the ggplot function. So this is the ggplot function. It is this function that is going to take your axis values. This function is going to take your axis values, but it's not actually going to plot the type of graph you want. I'm going to see what I mean by that in a moment. So there is this argument called mapping, which is equal to AES. So this argument mapping is equal to AES. It is where it is going to take your axis, your x-axis, and also your y-axis. That is now, when we will say we want to know the highly occurring diamond cut, that means our cut is going to be at the x-axis. You know the way a bar graph actually looks. Then our y-axis is going to be taking the number of times that particular cut is occurring. So we now say x is equal to cut. So when we say x is equal to cut, the graph is automatically going to show us the number of times that diamond cuts, various diamond cuts have occurred in the data. As you can see now, this is 1, 2, 3, 4, 5, 6. This is 6, our top 6 rows. We have ideal, we have premium, we have good, we have premium, we have good, we have very good. If you look at this now, you can see that good occurs twice, very good occurs once, premium occurs twice also, and we have ideal. So which means based on this particular table you are looking at now, you can see that the diamond cut, premium, are good at the highly occurring diamond. So our graph is just going to take the x-axis and show us which of these diamond cuts occurs most. But now we want to see for the whole data, which of these diamond cuts do we have most in our data. When I run this code now like this, if I'm to run this like this, you can see I have an empty graph. But I already have my labels already. You can see it. I have my axis, my x-axis, which is cut, the diamond cut. We have fair, we have good, very good, premium, and ideal. That is why I'm telling you that the ggplot2 library, or let me say the ggplot function, works based on grammar of graphics, which means it is based on a layer. The first layer you are giving is your data set. Then the second layer you are going to give is your axis. This is your axis that you are going to give in this particular layer. Now, the next layer I'm going to go to, they are going to use a plus sign, not a pipe operator. Please don't make that mistake. When it comes to ggplot2, they are going to be using the plus sign, not the pipe operator. Your pipe operator can only be used with other functions that are not in the ggplot2 package. Always try and take note of that. So now we are going to use the plus sign to pass it now to the function that is actually going to plot the kind of graph you want. So now I'm going to pass it to geom_bar, which is the function that plots you a bar plot. So when I now run this, you can now see I have a bar plot. So you can see we have a bar plot. Now from this, you can see that fair diamonds are the least occurring diamonds in our data. Good diamonds occurred as almost close to 5,000 times. We also have, and you know that time when you are viewing the data, we are having 53,000 plus of rows. So you can see this, the highly occurring diamond is ideal diamonds. with over 20,000 diamonds belonging to the ideal cut. Then we also have premium, we have very good, we have good, and we also have fair. So you can take this ideal diamond as the mode of our data, the most highly occurring diamond cut. Okay, now what if I also want to check for that clarity, diamond clarity? So you can see our diamond clarity. You can see that majority of the diamonds that fall to this category are not that clear, because we know that this IF diamonds is the most clear diamond, and most of the diamonds in our data sets are not as clear compared to these other classes. So you can now see, so we can now answer the question that, okay, we know that this SI1 class of clarity is the most occurring diamond clarity in that particular data. Okay, now if you look at our graph, this graph is not looking beautiful. We can also make this graph to look more colorful and beautiful. How do we do that? Let me go back to the cuts I was using. So I was using cuts, so you can see this is our data. So I want to make this data very, very beautiful. Then how do I do that? So I'm now going to come here and say fill is equals to cut. So it is going to fill this diamond based on the variable cut. When I run this, so you can see that now my diamond graph, this plot that is showing me the various diamond cut has been filled by diamond cut. Look at the legend. You can see the legend where this color, this should be, let's call it indigo, for example. It's fair diamonds. We have the blue good diamonds. We also have something looking like a cyan color, very good. We have green premium and we have yellow ideal. So this is also more, it makes the graph more appealing. It makes it more color when you use a color on your graph. So that is what the fill argument inside this aesthetics does. Please, I want you to take note. This is used for taking your axis. Why this is used for plotting the kind of graph you have. We are going to be changing these functions as we go into other kind of data visualization. We're going to be changing these functions, but always make sure that most of the time you are going to be using this. So this is your data, then where you are going to put your axis is going to be here. So that is your X and Y axis, and also maybe the kind of fill you want, your fill settings. What if I say color is equals to cut? What do I get? When I say color is equals to cut, you can see that this diamond has actually changed. Its fill still remains the default fill, but the outline you can see. So the color argument is meant for the outline. As you are looking at it, the color argument is meant for the outline. So let me expand it for you to have a clearer view. So this is the color outline. So when you use the color argument, it's meant for the outline. When you use the fill, it is meant for the whole color. So now let me revert it back to fill is equals to cut, because the graph looks best like that. So fill is equals to cut, as you are seeing it. So this is our graph. You can show this to someone and say, okay, this is diamond occurring most. So anybody even looking at this graph can actually even see it self-explanatory. So that's one thing about data visualization. So the next kind of graph I'm going to be plotting is the horizontal bar plot. So what is the difference between horizontal bar plot and the vertical bar plot? Well, the horizontal bar plot is just, there is no difference actually, it's just the position of the axis. So the x-axis actually becomes, it actually comes back to the y-axis position, while the y-axis comes back to the x-axis position. So they just swap places. That is just the difference between the horizontal bar plot and the vertical bar plot. So they just swap places. So in the horizontal bar plot now, because if you see, it's called a vertical bar plot because the bars are actually vertical as you are looking at it. While the horizontal bar plot is called horizontal because the bars are horizontal. So once you just swap the position of this x to y, if I, instead of saying x is equals to cut, let me just copy this and paste it. Then I just change this x to y. You can see that they have actually changed position. So this is the difference between a horizontal bar plot and a vertical bar plot. There is no difference between them. This is just the little difference. You just need to change the x and the y. Once you change the x to y, you have a horizontal bar plot. Once you change the y to x, you have a vertical bar plot. So it's based on your choice. But most of the time, I'll advise when you have a lot of values in your variable. Like if you look at that clarity now, let me give you clarity. So let's use the clarity. Fill is equals to clarity. You can see the way the graph looks like. So when you have a lot of values, like in this situation now, so let me expand the graph. So most of the times in this situation now, we're having, as you can see, we're having 8 values in our clarity variable. Most of the time you can have like 20, you can have like 10. So the best kind of graph you are going to be using is going to be the horizontal. Because when you say you want to make it vertical, the space might not actually accommodate it, and the names of your labels will be coming together. They are going to be joining together. So that is why sometimes it is best for you to use the horizontal bar plots. Let me show you an example now with color. We have a column called color. We have a column called color in our data, which is a diamond color. So let me use a vertical bar plot, so you can see it is a variable that have a lot of values. So this is for diamond color. We can now see that the diamonds with the color G occurs the most, then diamonds with the color G occurs least frequent. Now another thing I want to point out, you mustn't necessarily fill it by the same, let's say you have your x-axis as color, or let me go back to cuts. Let's say you have your x-axis as cuts, and you have your fill as cuts. So you mustn't necessarily be having the same variable name in both the fill and the cut. For example, now I can check how it is actually different based on clarity. When I say fill is equal to clarity, it is going to group it for me. So you can see it has grouped it for me. They show me various diamonds clarity. So for each graph is a diamond cut, while each color inside this graph is diamond clarity. So I'm jumping the gun here. I'm going back to the other type of graph we're going to be talking about. So this is another way of doing it, but I'm going to go to the back. This is called a stacked bar graph. As you can see, it is stacked. So each column is a diamond cut. But in each column, we have various diamond color, and these colors actually shows us diamond clarity. You can see this color here, this indigo color here, is not even showing that much, which means that the diamond clarity I1 is not that much. As you can now see also this color, you can see this blue, you can also this cyan, you can see this color, we can see that they are occurring the most in almost all the graphs. So this is another way of seeing how diamond clarity varies between various diamond cuts. And also let me point you to something. You can actually store this as a variable. You can store it as a variable. You can call it horizontal bar graph. So you can store it as a variable. So you can see it's stored as a variable. So when I call it, my graph is going to be called. Sorry, H is supposed to be H. So when I call this, so you can see it, I'm going to have my graph. So this is another. So now you can also plot a horizontal bar plot using the cohort flip function. So you can see that we also have now a horizontal bar plot. So see, this is one unique thing about ggplot2 or even R in general. There is different ways of doing things. I just showed you a way of plotting an horizontal bar plot by just changing this x to y, and this is also another way of plotting a horizontal bar plot by using the cohort flip function. It's based on your choice. You can use anyone that you feel comfortable with. You are free to use anyone, and nobody will hold you responsible. You are free to use any method of plotting your graph. Just make sure your graph looks appealing and it also looks sensible, and someone can also get reasonable insights from it. So the next kind of plot I'm going to be talking about is the stacked bar plots. So I've already just dived into it, so I already showed you already inside when I was explaining the vertical bar plot. So it's just simple and easy. So most of this is just the names that are changing, but the way you write the code there's no difference. So I just copied this and let me paste it to the stacked bar plot. Once you just change your field to another variable that is categorical, either color, for example, let me use color. Okay, it's spread as color. I think in the table, in the data, it's spread as color. So you can see it. So you can see for diamond color. So now each column is a diamond cut, as you are seeing on your screen. Each column is a diamond cut, and each of these colors is a particular type of diamond color. Now, why you use the stacked bar plots in cases is when you want to know how a particular variable is how various variables is in a particular variable. So now we already have the main variable we're dealing with, which is diamond cut. So I've already seen it that, okay, we know that ideal diamonds occurs the most. But now, out of this ideal diamond, you now want to know which particular diamond color occurs most in ideal diamonds. Then you now use your stacked bar plot. A stacked bar plot is going to show you for each diamond cut which diamond color occurs more frequently. When you take a closer look now, you can see the ideal column. As you are looking at it, you can now see that, okay, color G actually occurs most, followed by color F. As you can see, this is the number of times it occurs. You can say, okay, color G occurs the most. Then we also have color F. We also have color F. We also have color E too, which is, I think, after color G, then color E also occurs frequently, then color F, then we can now see color D. So this is a way of knowing that, okay, in the ideal diamonds, color G occurs the most. So these are kind of ways you can use to interpret information or extract insights from your data set. So this is called a stacked bar graph. You just need to change your field to another variable name. Once you change your field to another variable name, you have a stacked bar graph. So the next kind of bar plot I'm going to be talking about is the grouped bar plot. So the group bar plots and the stacked bar plots are almost similar. It's just the way they represent or explain the information. So now, in the situation whereby we have the stacked, as you can see from the name stacked, this this color are stacked on each other. As you can see, they are both stacked on each other. That's why it's called a stacked bar plot. So let me just copy this. Once I copy this and paste it here, so you can see we have our mapping. So this is the function, this is our argument mapping in the ggplot function, which takes our axis using the AES function, or they call it the aesthetics function. I told that this ggplot2 works on layers of, or let me say grammar of graphics, which is based on layers. You pass your data set first, then you pass your axis, then you now pass the type of graph you want to plot. So now under geobar, I'm going to pass a particular argument called position, which is equals to George. So this is going to magically transform this stacked bar graph which we have initially. This argument we gave position is equals to George is going to transform it to a grouped bar graph, as you can see. So you can see the grouped bar graph. So it is similar to the stacked bar graph, just that they explain information in different ways. So they are both explaining the same thing, but explain it in a more different way. So in this place, it's going to assign each color a column. While in that place, it's stacked all of them in the same column of ID. But under this ID, we have various columns explaining the diamond color. So we can now see that on our ID, we also have color G to be more frequent. So explaining the same information, but in a different way. But there's situations where it is not advisable to use this kind of graph. Let's say, for example, now you are having, let's say we have 10 colors. If we want to use 10 colors, the graph is going to look clustered and disorganized. So it is not usually advisable to use grouped bar charts in that kind of situation. The best will be the stacked bar graph. So when you are having too much values in a variable, too much factors in a variable, too much categories in a variable, please try and use the stacked bar graph, else your graph is going to be looking clustered and disordered. So now I'm going to explain to you about the box plots, how you can plot a box plot, the ggplot2 package. So now, first of all, let me just go here and copy this code. I'm just interested in this. I told you our axis. Paste it and let me remove the field. So this is now, in this situation now, we are going to be using cuts. So I told you that you pass your data first. After passing your data, then you pass your ggplot function. So this ggplot function actually carries your axis, or let me just say your labels. So when I run this, you can see we have a plot with our diamond cut. We can only use a box plot when you are plotting a categorical data against a continuous data. So you cannot use a box plot for a categorical data and a categorical data. You cannot use a box plot for a continuous data and a continuous data. It must be a categorical data versus a continuous data. That's when you use a box plot. So we want to be using the price now. I'm going to be comparing the diamond cut and price. I'm going to say y is equal to price. So you can see I already have my graph plotted with the price and the diamond cut. I'm now going to use the plus to pass it towards my box plot layer, which is geom box plot. Please always take notes, don't use the pipe operator, use the plus operator. So this plus is going to pass your labels or your axis, is going to pass it to the geom box plot function, which will now plot your box plot. So when I enter, you can see I have my box plot. So this is my box plot. So what do you think we can do to this graph now to make it more appealing? You guessed right, we are going to give it fill or color. So most of the time when I'm using box plot, I prefer to use color instead of fill. That is the line color. Because for example now, if I'm to use fill, so let me use fill is equals to cuts. If I'm to use fill now is equals to cuts, I get something like this. But I prefer to use color is equals to cuts. So you judge yourself which looks more beautiful. So you can judge between yourself which looks more beautiful and you can use it. But I always like to use my line colors anytime I'm dealing with box plots. So this is the box plot of diamond cuts against diamonds. You can see the y-axis carrying price of diamonds with scale of 0 to 1,000 to scale of 0 to 15,000. So one thing I want you to know about the box plots now, I'm going to show you how you can interpret a box plot. For those of you that are new to box plots, you can see here we have a box. So this box, there is a particular line in this box. Well, this line that you are seeing is the median price of diamonds belonging to each diamond cut. So when you see a line, you can trace it back to the y-axis and see that, okay, the median price of diamonds belonging to this cut falls in this range. You can also check off that of premium. The median price of diamonds that fall in the premium cut are traced back to this range. Now, from looking at this plot now, which is the highest? Well, you can see that we have premium diamonds and also fair diamonds to be almost close to each other. But from what I'm seeing, since premium diamonds are the highest, either they are on par, or it seems premium or fair diamonds, one of them seems to have a median that is very high. One of their median seems to be very high, either the premium or the fair diamonds. Well, this signifies that expensive diamonds are usually found in the premium category. You can also find expensive diamonds in the good category and also fair category. This explains the median, that if median falls in this range, you can see from here we should be having, if this place is 5,000, then around this side we should be having like 2,500. So which means at this position that you are seeing my cursor, we should be having something like 3,000. So we have what diamond price that are around 3,000 at this range. So we should be having diamond price around 3,000. So we should be having, that's in this axis, we should be having diamond price around 3,000. And why if you now come to the ideal diamonds, you see ideal diamonds even below 2,500. So ideal diamonds are below 2,500. So let me go back to my console and check for the range of diamonds. So let's check for diamond range. You can see diamonds, then price. So you can see diamonds range from 326,000 to 18,823. So, and when we go back to our data set also, so you can see that the price of the diamonds in US dollars, you can also see the range also of the price in this place. So we know that our least diamond is 326 and most expensive diamond is 18,823. So now let's go back to our box plot and continue the interpretation. So now this line is just telling you that the median price of diamonds in ideal falls in this range. So the box plot divides a particular category into 4 parts. So in this category, we have this line that you are seeing here is called the lower quartile. So it divides the category into 4 parts. We have the lower quartile, we have the median, second quartile, and we have the third quartile. So one thing you need to know about the box plots, long story short, is that the box plot shows you the median values of the price of diamonds. So with this box plot, you can know which diamond category is actually expensive. So you can see now we have premium diamonds and fair diamonds to be competing with each other. And we have ideal diamonds. Since we know ideal diamonds is the lowest quality cut, so we have ideal diamonds to be having prices that are below the median of other diamonds. So this box plot that you are looking at has the first quartile, the second quartile, the median, and also what the third quartile. So any groups that falls into here falls above the median. So any diamonds that you see in this range, which price in this range falls above the median. Any diamonds with price in this range falls below the median price. So with this, you can know that okay, we have diamonds. Most of the diamonds under ideal are above the median price, and we have just few diamonds in ideal that are below the median price. While in this place we also have the same thing, majority of diamonds are above the median price, this line, and we have also diamonds too that are below this, but the diamonds above the median price are much than the diamonds below the median price, as you can see it. So this box space actually shows us that okay, we have a lot of diamonds above this median price, and we also have a lot of diamonds below this median price. It's just as easy as that. Just take note that when you want to plot a box plot, you are plotting it against category. You are plotting category against continuous variable. So I can choose to use diamond carats now, for example, instead of diamond price, which is the weight of a diamond. So let me change it to diamond carats. See now, by changing it to diamond carats now, you can see we know that most of the diamonds. Let us check the range of the carats. Let's check for the range of diamond carats. So diamond carats range between 0.2 to 5.01. Check our axis. We have diamond carats around 5.01. So these are usually called outliers. So what this explains to us is that majority of diamonds in this data fall between the range of 0 to 1 point. Let's just say 1.5. So any diamond that you are seeing above 2, they're having carats above 2, 3, 4, or up to 5 are very few. They are not much. You can see them. You can see 1 year, you can see 1 year, you can see 1 year. That is, they are called outliers. These are diamonds with extreme carat values, so they are not that much. You can see we have a diamond of 5 carats here. So you can see these values are not that much, but majority of the diamonds in this data set fall between 0 and 1.5. Majority of them, and you can see fair diamonds have the highest carat value because the median of fair diamonds is higher than that of any. So the carat value of fair diamond is around 1. while the carat value of ID diamond is the lowest. So they fall around 0. A little bit above 0.5. Let's just say 0.55. So the carat value of ID diamonds fall around the range of 0.55. So which means in this situation, you can see that fair diamonds have higher median carat value and ID diamonds have the lowest median carat value. So, and also if you look at it, you can see that also in the fair diamonds, most of the diamonds under fair diamonds fall below the median carat value. And also in the ideal diamonds, most of the diamonds in ideal diamond cut fall above the median carat value. So this explains to us that though the median carat value is around 0.55, but most of them fall above that range. So this is just telling us that, okay, the median carat value of ID diamonds is 0.55. Most of these diamonds fall above the carat value of 0.55. While in that case of the fair diamonds, most of them, though the median is 1, which is the highest, most of them fall below the median carat value of 1. So this is another way of interpreting your data. That's why I say that the box plot is very comprehensive. When you look at the box plot, you can get a lot of insights from your data depending on the question, the kind of question you are asking. And you can also know the highest carat value, which is 5, and it belongs to fair diamond. Look at it here. This is it. We have a lot of outliers. Can you see a lot of outliers? A lot of diamonds with high carat value. So a high carat value can explain a lot of things, since maybe a diamond is impure, or maybe a diamond is not that clear. So it can also mean since that maybe because now look at the diamond cut is fair, but it's having a high carat value. So I don't know much about diamonds, but if you are someone that is a diamond enthusiast, you can get a lot of information from this particular graph that you're looking at. So this is for comparing cut against carat value, while in that previous graph I was comparing cut against price of diamonds. The next kind of graph I'm going to be talking about is called the histogram. So the histogram and the bar plot are similar in the sense that both of them use columns to visualize data, but just a little difference. So in the histogram, we use it to compare we use it to check for the distribution of a continuous variable. Unlike the bar plot, which we use a categorical data, we check for the distribution of a categorical data. So we want to know how many diamond cuts we have 5 diamond cuts. So I want to know the distribution of these diamond cuts, the count of these diamond cuts in the data. Then we use the bar plot. But in histogram, we cannot use histogram for the diamond cuts, because the diamond cut is a categorical data. So this is where we are going to be using histogram for a continuous variable. That is a variable measured on a numerical scale, something like carat, diamond carat, or diamond price. That is where we can now use the histogram, because the histogram is going to show us how these values are distributed to each other by grouping these values into various classes. So let me plot the histogram for you. I'm going to say diamonds, and I'll pass it to the ggplot function. Say mapping, which is equal to AES. So this is where I'm going to be giving our labels or our axis. I'm now going to say X is equals to price. Then when I run this, you can see I get my graph ready-made already. Now I'm going to pass the geom histogram function. So this geom histogram function is going to plot a graph, a nice looking histogram for us. So you can see we have a nice looking histogram. So this histogram is now showing us the distribution that values between 0, you can see the price of the diamonds ranging from 0 to almost going to 20,000, close to 20,000. But it is telling us that values between 0 to 5,000 are occurring most in the data. So we have a lot of diamonds falling safe between 0 and maybe a particular value here. Let's just take this as 2005. So from 2000 below, we have a lot of values falling in this range. We have a lot of observations or a lot of diamonds falling in this range. So why, when you go up, the higher the price, the lower the number of diamonds falling in that particular price. This is what we can use the histogram for. It allows us to check for the distribution of numerical values. Now, when you now look up, you can see it is telling me that start bin using bins equals to 30, peak value is bin width. So I told that the histogram groups these values into classes. These classes are usually called bins. You can see the bins. When you have to count all these bins, you are going to have 30 bins. As you have seen above, bins is equal to 30. So it wants us to pick a better value with bin width. If I'm to increase this value, instead of 30, I'm going to use another higher value. I'm going to have a very smaller groups or smaller classes. So now let me just reduce these bins to, for example, 20 by giving the argument in the geom histogram function. Bins is equals to 20. When I do that, you can see now the number of bins are reduced. So why they were suggesting formula time to use a better bin width was because there are some values, as you can see here, some price as you can see, that falls in this range, which we are not actually seeing that time when we use bins is cost to what, 30, but now we can see it. We can also reduce the bins. I can use bins of 10, a class of 10. When I use a class of 10, you see I have something like this. So you can see our diamonds price. This is our diamonds price. We can see a lot of values are falling in this range. Diamond of 15,000, sorry, count of 15,000. While we have diamond price, a lot of diamonds between 0 to 5,000 falls in this range. So what if I increase the bin, for example, bins to 100? So I'm going to get very small classes or smaller bins. It also allows me to see more about this distribution, because diamonds price, as you are looking at it, actually diamonds that fall within this price of 0 to 2,500 are much. But when you now go from 2,500 to 5,000, you can see that it is reducing and it also increased again, and also coming down. So while it is coming down, some are actually also increasing. So this is how you can get information from an histogram. So histogram is very important. It is also very useful. It allows us to check the distribution of continuous variables. The next plot I'm going to be talking about is the scatter plot. So the scatter plot is used for finding the relationship between two continuous variables. So we have two continuous variables that are measured on a numerical scale, and you want to know the relationship between these two variables. You want to find the relationship between these two variables. You want to know how these two variables are related to each other or correlated to each other. Then you use the scatter plot to visualize the relationship. So now, if you go back to our diamond data set, we have the column carat, we have the column price, and both of these variables are measured on a numerical scale. So how do I visualize the relationship between these two variables? I'm going to pass the diamonds data set to the ggplot function and give mapping. It goes to our aesthetics. So I'm going to give X as price and Y as diamond carat. So when we run this, we're going to have an empty graph with our X and Y axis. So the function I'm going to use to plot a scatter plot is geom_point. So after running it, you are going to have a graph like this. So this is our scatter plot as you are looking at geom_point. So you can see the relationship between diamond price and diamond carat. So you can see that as a diamond price increases, look at the price of diamonds as it increases, we are likely to have a higher carat. So as the diamond carat also increases, we are likely to have a higher diamond price. So this graph actually explains to us that there is a positive relationship between diamond price and diamond carat. If we look at some of the diamonds here, most of them fall on a higher diamond price. If we also look at some of those with lower carats, they fall on a lower diamond price. So what if we want to categorize our scatter plots based on diamond cuts? Then we can use color is equals to cuts. So I'm going to get a point in which the various diamonds are grouped. As you can see, various diamonds are grouped by their cuts. Now I want to find the relationship between price and, let's say, the diamonds, price and the length of the diamond, which is X. So this is the relationship between the price of a diamond and its length, as you are looking on the screen. So you can see that diamonds with higher lengths are likely to have higher price. So the scatter plot is very useful when you want to find the relationship between two variables. As you have seen, we have shown the relationship between price and carat, and now also have, as you are seeing on your screen, this is the relationship between diamond price and diamond length. So the last kind of graph I'm going to be talking about is the line graph. It's called a line graph or a time series graph. So a line graph allows you to check how a value changes with time. So when you already have a data on time that was already saved, let's say by a particular period, maybe it was saved monthly or yearly, or it was saved weekly or even hourly. So this is usually called a time series data, because this data is already stored by time, it was saved in time. So this is the reason why I actually brought in the economics data, because this diamonds data is not based on time, but the economics data I told you is already based on time. It's about US, which explains their population. So let's check the US economics data. So you can see the US economics data, date, PCE, POP. This is savings, and this is number of unemployed, and this is also population. So the first thing I want to check how population has been changing with time. So now let us check the range of the dates in the economics data. So I'm going to use the range function to check the range dates. So you can see that this economics data ranges from the year 1967 to 2015. So now I want to find how the population of the US changes monthly from 1967 to 2015. So I'm going to use the economics data. I'm going to pass it to the ggplot function and use mapping is equals to AES, our axis, then X is going to be equals to, because our x-axis is the time, so we're going to be seeing X is equals to dates. So X is going to be equals to dates, and our y-axis is going to be the value that we're interested in, or the variable we're interested in, which is what population. So that is POP. They will now pass it to the function geom_line. So when you run it first, we have our graph here. As you can see, it's the population of US monthly and also the dates. Then when I now pass it to geom_line, the population of US has actually been increasing up to 2015. So let us check the population of unemployed people, the unemployed population in US. I want to change this POP to variable unemployed. So the population of unemployed has increased in some particular years and decreased in some particular years. It has increased in some particular years, has also decreased in what particular years. So you can see now why the highest population of unemployed was shown in the year 2010. It showed a massive increase in the number of unemployed in US in the year 2010, but it has now been decreasing from that year. So it has been decreasing from 2010 going up to the year 2015. It has been decreasing, but the peak of unemployed population was at 2010. We also have peak of unemployed population around 1980s. So it should be 1980, let's say 1983, it should be around 1983. So this is a time series graph or a line graph. So you can see that it is showing us how the number of unemployed population has been changing in the US throughout the previous years from 1967 to 2015. While at 2015, the number of unemployed was highest, but it was reducing up to the year 2015. We will have had data from 2015 maybe to present. We'll have been able to know how also the population, number of unemployed population has been changing throughout those years. So the next thing I'm going to be talking about now is the labeling. How can you label? You can look at the previous plots plotted in the last lecture. We see we have dates and we also have what's unemployed. I want to give my graph a title, and I also want to change the labels of the X and the Y axis. I'm now going to use the plus and pass it to the function labs. So this labs is going to change the label for the X and Y axis. I'll now say X is equals to the dates, or let me see year. Then I can now see Y is equals to unemployed population. I can now say title is equals to line graph showing, or let me just put change in population, change in unemployed population in the US from the year 1967 to the year 2015. So you can see now I have my title, change in unemployed population in the US from the year 1967 to the year 2015, and you can see here I have unemployed population as my y-axis title or my y-axis label, and I have also the year as my x-axis label. So this is how you conduct your labeling in all your graphs. So you can do that for also all other graphs. Just make sure you know the function, which is labs, and give the argument x is equals to year. You give the argument y is equals to unemployed, and also give the argument title is equal to change in unemployed population in the US from the year 1967 to the year 2015. That is how you label your graphs.